Good morning. My name is Dr. Shivali Verma, and I am taking engineer physics and its application. Today's our topic is wave function. It is from the unit 2. As we know that the, when we are going to quantum physics, the particle becomes a matter, the particle become a wave, as we know that. When particle become a wave, we have to be describe that wave as a matter wave, and we know that de Broglie said that whenever the particle is moving with the velocity, one wave-like nature is associated with it, and this wave-like nature is known as a matter wave. But now we have to be represent this wave-like nature in a mathematical form. For representing this matter wave in a mathematical form, we in quantum mechanics we are using a one wave function, and this wave function describe the quantum state of an isolated system, or we can say that it can be and, this wave function encapsulate all the valuable information about the particle, such as a position, momentum, and energy. Okay, what is actually wave function? If in a easiest way we can explain, it represents the matter wave. Actually, the part when moving the what is the matter wave? As said earlier, matter wave is a wave which is associated with the moving micro particle, and this is given by the de Broglie's. So, what is wave function now? Wave function is a mathematical description of a matter wave, and it's contain all the information about the particles, such as its momentum, its position, and its energy. Or we can say that wave function is a quantum represent a isolated quantum state. Isolated means what? Means that each electron having their own matter wave, and therefore their own there will be their own wave function. One particle having a one wave function, another particle having another wave function. That's why we can say that wave function describe the isolated system also. Okay, this wave function is basically denoted by a Greek letter which is known as psi. This is written over here. We pronounce this as a psi. Okay, now we are going towards the thing that what is the nature, what is the mathematical nature of the psi? So the mathematical nature of the psi is a complex. Its nature is a complex because psi contain not only the information about the position, it's also contain the information about the phase. So that's why we need psi in a complex form. Now, psi is depending upon what? Psi is depending upon the position and time, as classical mechanic wave is mechanics wave function is depending upon the position time. Therefore, it is well known that psi is also depending upon the position and time. Now, psi itself is not going to be interpreted anything. Therefore, Morse said that we have to be change psi into its real form. So, how we can change a psi in a real form? Why psi is not interpreted anything? Because it's a complex, and complex values are not able to describe any physical event. Therefore, we have to be change psi in its complex form, complex to the real form. So, how could we change psi in its real form? So, as we know that when we multiply any complex number with its complex conjugate, then we will get the real number. So, here also we do same thing. We multiply psi with its complex conjugate, and what we will get is psi modulus square. Okay, so it's again a um, a real form. Now, the thing what this psi square explain, what how we explain this psi square, which physical quantity is explained by the psi square. So Bohr says that the psi square represent the probability density of finding the particle at any given position and time. Okay, or we can say that it is when probability of finding the particle we show by the the integration of psi square dx is equal to 1. But if the probability is 1, then the value of p becomes 1, and this is known as a normalization condition. From where this concept came from, where the de Broglie said that this analogy came. So this analogy came from the classical mechanics only, because in classical mechanics, whenever we are talking about the y, yeah, or we can say talking about the amplitude of any classical wave. So what is the amplitude of any classical wave? It is represented by the y, and y is also the we can say that function of position and time. And why by knowing the y, by knowing the y, we can know the energy density or energy intensity of any wave. How? Because we know that intensity in classical mechanics, the intensity is directly proportional to the amplitude square. It means that y square. So if the value of y square is more, we can say that the intensity of that wave, it will, it may be a sound wave or a water wave or a light wave. Its intensity is high. If y square value is high, its intensity is high. If y square is low, intensity is low. So y square is related with the intensity. And as we know that what is intensity is the total energy per unit volume. Total energy per unit volume. So for a given volume, V is constant. And what is total energy? If we are taking a photon energy, then we can say that the energy of single photon is h nu. And if there are n photon, then the total energy is n h nu divided by V. Or we can describe the intensity of light is like that. It is equal to the total energy divided volume, means n h nu divided by the V. So if for a particular frequency and for a particular volume, this h nu v is a constant. Therefore, we can say that I is directly proportional to v square, and sorry, y square, and y square is directly proportional to n. Now, what is n here? N is a number of photons. So y square is given information about the number of photons. So similarly, the in a quantum physics, we can assume that the psi square is also give the information about the particle, because photons are we consider photon as a particle. So if y square is given the information about the particle, by this analogy, psi square also represent the give the information about the particle. But in quantum physics, Heisenberg said that the position and momentum of the particle cannot be determined exactly. Therefore, we cannot say that the psi square give the exact position of the particle. Therefore, it likelihood would, it is represent the probability. It means for the probability of finding the particle, or we can say that the psi square represent the probability of finding the particle. So, on the basis of this analogy, Bohr interprets that psi square represent the probability of finding the particle, and we can represent it by p. And what is the value of p? P is a integration of psi square ds in a one dimension. If there is a three dimension, it will be a volume integration of psi square dx dy dz. Okay, so this is the probabilistic interpretation of Bohr's. Some interpretation, one more interpretation is given by the Copenhagen interpretation. Now, Copenhagen interpretation. What is this Copenhagen interpretation? Copenhagen says that act of the measurement causes a wave function to collapse into a single definite defined state before measuring the system exists in the superposition of the possible outcomes. Means what? It means that until and unless we are not observe the particle till time the particle is possible in its all superposition state, means all possible outcomes, and we cannot say that that particle is in a definite state, but as we see it, as we measure it, the all the possible states are collapsed into a one definite state, and this is the Copenhagen's interpretation, where wave function is collapsed. So on the basis of this interpretation, nobody can say that particle is in which state until and unless we cannot be absorb it sorry observe it. Okay, so the next thing is that the property of what are the property of wave function. So wave function must be a single valued because every particle having their own wave, that's why wave function must be a single valued. Next thing is the wave function and its first derivative must be a continuous because it is a function of a wave, and waves are the continuous in the nature. Next thing, it must be a finite everywhere, go to zero as distance increase to the infinity. It must be a finite. It is not a infinite, because if the probability, because wave function is a probabilistic thing, so if the probabilistic thing is a infinite, then the physical laws are going to be a vanish, and therefore wave function must be a finite. Next be a property of wave function is that the total probability of finding the particle in all space must be a 1, and it will be expressed by the integration from minus infinity to plus infinity psi square dv is equal to 1. It means that if a particle is finding somewhere or in a some energy state, then its probability must be a it's 100%, and in that condition the wave function is normalized. So this is all about the wave function. Shan, in our next topic, we can take Schrodinger wave equation. Thank you very much.